Okay, in this video, we're going to find the equations of parabolas, quadratic equations, given different scenarios. And just want to say that this is a great review of parabolas in general. So I'm going to go through and actually write it in different forms, and you'll see as I go. So the first one says find the equation of a parabola, which, by the way, we all remember parabolas look like this. So we're looking for the equation for parabola has a vertex at -3, -2. We're moving it left 3, down 2. So I'm going to take my parabola, move it left 3 by doing x plus 3 squared, and down 2. So now this has the vertex we need. However, and I changed the problem, it was messed up before, I want it to pass through this point. The only way we can get it to pass through this point is by stretching or compressing it somehow. I'm going to put an a value out here, and we're going to force it to stretch or compress through that point the same way that we force linear equations to do what we want them to do. And that's by plugging it in. We're going to plug in this x and this y. We have a value of 4 for x. We're looking for an a value. When you plug in -2 for, 4 for y, when you plug in -2 for x, great things happen. -2 plus 3 is 1. 1 to the second is 1. So when you solve this equation, a times 1 is a, move the -2 over by doing +2, we get an a value of 6. So I'm just going to erase everything else, erase my a, and I'm going to put that 6 there, and there's your equation. Now I do want to write this in the other two forms. The way I'm going to write it in the other forms is, first off, I'm going to distribute this out. I'm going to do x plus 3 times x plus 3, and I'm going to do it up here, x plus 3 to the second power. That's going to be x times 3, 3 times x, and 3 times 3. And that gives me a value of x squared plus 6x plus 9. I'm then going to multiply that by 6. And I'm going to go ahead and write that down. So 6 times all 3, that's going to be 6x squared plus 36x. And it's going to be plus 54, which will actually combine with this and give me plus 52. So there it is in standard form. And you could try to factor that. I don't think it's going to be factorable, so we're not going to try to write it in the third form, but you could use bottoms-up factoring to where you move the 6 to the end, multiply, and do that whole number, but we're going to leave those two as our answers. Now, just to show you, my vertex is -3, 2. We want it to pass through the point -2, 4, and I'm going to go back and show you right here. This is the actual parabola. Does it pass through the point -2, 4? Let me get it to where it looks a little bit better. -2, 4, we can follow. Let's see if we can do that. -2, 4 is going to be about right in there somewhere. You can see it does pass through it. It does have the correct vertex. So what I'm trying to show you is you can always use Desmos to check these answers. And what else I like about it, notice I graphed both of them here. There's the one form, the vertex form, and there's the standard form. Notice they lie right on top of each other. It's the same equation. All right, back to it. And you can do that on all of them. I'm not going to. The next one has zeros, x-intercepts. Now we're going to use a different form for this. If it's got an x-intercept at 8, we know that x minus 8 is a factor. If it has an x-intercept at 4, it means x minus 4 is a factor. However, we want it to pass through this point, so we're going to stretch it to make sure it passes through the point 7, 3. How do we do that? We plug it in. So therefore, I've got a y value of 3. I've got an x value of 7, so we're going to plug it into both of those. 7 minus 8 is -1. 7 minus 4 is 3. You can clean that up if you want to, but this is -3. We're going to divide by that, and that gives us an a value of -1. So therefore, I'm going to go back up here. I'm going to erase my a, and I'm going to put my -1 out front, and that's your equation. Now, to get it in my other forms, I can get it in standard form just by multiplying it out. So I'm going to do x minus 8 times x minus 4, and I've still got my negative out front, so I'm going to do it down here. It's going to be x times x times -4, -8 times x, and -8 times -4. This is -12x. When you distribute that negative, that's going to be y equals -x squared, a positive 12x, and a -32. There's standard form. And then to get it in your other form, your vertex form, we have to complete the square. Quick reminder, as you're completing the square, I'm going to do it in a different color here. If there's anything in front of x squared, it must be factored out of the first two terms. So we have x squared minus 12x we're going to leave that minus 32 alone. Half it, square it. We're going to add 36, but we really subtracted 36. So on the same side, we also have to do the opposite of it. We're going to add 36, and we're pretty much finished. So you have y equals, leave the negative there. And you can see that same negative a value as we saw before. We're going to factor this. That's going to be x minus 6 times itself. And then combine those, and that gives us a plus 4. And there you have it in vertex form. Okay, last one. And this is probably the trickiest of the three. It's still not bad, but they give you 3 points. Now, what we're going to do here is we're going to have a system. This is what a quadratic equation looks like in standard form. However, they did you a favor on this, and a lot of times you'll see this. They actually gave you the y-intercept. When you plug in 0, you're going to get a 3. The y-intercept of any line, parabola, or anything is always located right there. Okay, so we use that to find the y-intercept, and now we've got to make sure it fits through both of these points. How do we make sure it fits through a point? We plug that point in. So when I plug in 9, I'm going to get, when I plug in -1 for x, I'm going to get 9 for y. So let's plug that in. You get 9 equals, we're plugging in -1 for both x's. -1 times -1 gives you 1a. -1 times b gives you a minus b, and then you still get your 3 out there. We also have to make sure it fits through this point. So when I plug in 2 for x, I'm going to get 3 for y. So that's going to be 3 equals 4a. Plug in 2 for x, that's going to be 2b, positive 2b, plus 3. We now have a system. We're going to solve the system. It's a very easy linear system. I'm actually going to take this plus 3 in both of these and move it to the other side and rewrite this system. That's going to give you a minus b on the first one equals 6. The second one's going to give you 4a plus 2b equals 0. You can solve systems by substitution or elimination. Since this one's lined up already, I think it'd be perfect for elimination. So I'm going to try to get my b's to eliminate. I'm going to multiply my first equation by 2's. 2a minus 2b equals 12. 4a plus 2b's equals 0, and that's the reason that I did that. 6a is equal to 12, so now you have an a value. And now that you have an a value, in order to find a b value, you just plug it back in. So that'd be the best place probably to plug it in. 12 minus b equals 6. When you solve that out, you get a b value of 6. Go back to your original equation, and you now have the equation of that parabola. Let me erase all this in the middle so I've got room to finish this. So you have an a value of 6, so that's going to be y equals 6x squared. A b value of 12, so plus 12x plus 3. So that's your first answer. You can try to factor that. I'm not sure. I don't think that's going to factor, so I don't think we're going to be able to put it in x-intercept or factored form. But I am going to complete the square to try to get it in vertex form. Factor the 6 out of the first 2 terms. Oops, let's leave a little bit more space. Leave the plus 3 on the outside. We're going to complete the square by taking half and adding, or half and square it and adding that. We really added 6, so therefore we're also going to subtract 6, and we're pretty much finished. Y equals, the 6 is out there. This factors into x plus 1 times itself. 3 minus 6 gives you a -3, so there's the exact same parabola written in vertex form as well.